Hello everyone, in this lesson we are going to focus on SAT math hard questions and answers of numbers and operations. Let's start with the first question. A, 2a minus 1, 3a minus 2, 4a minus 3, then it continues. For a particular number a, the first term in the sequence above is equal to a, and each term thereafter is 7 greater than the previous term. What is the value of the 16th term in the sequence? Since the second term is 7 greater than the first term, that means 2a minus 1 minus a is equal to 7. If we solve this simple equation, then a is equal to 8. The sequence is 8, 15, 22, and then it continues. You can either continue to write out the sequence until the 16th term, or realize that the 16th term is 16a times a minus 15, which is equal to 16 times 8 minus 15, which is equal to 113. That's the answer. Therefore, the answer C is correct, or the choice C is correct. Now let's go to the next question. Question 2. A bag contains tomatoes that are either green or red. The ratio of green tomatoes to red tomatoes in the bag is 4:3. When 5 green tomatoes and 5 red tomatoes are removed, the ratio becomes 3:2. How many red tomatoes were originally in the bag? The number of green and red tomatoes are 4n, 3n, respectively, for some integer n. In this way, we can be sure that the green to red ratio is 4n over 3n, which is equal to 4 over 3. Now we need to solve the equation 4n minus 5 over 3n minus 5, which is equal to 3 over 2. Cross multiplying, then 2 times 4n is 8n minus 10, which is equal to 9n minus 15. If we solve this equation, then n is equal to 5. There were 3n or 15 red tomatoes in the bag. Then the number of red tomatoes is 3 times 5, which is equal to 15, or 3n equal to 3 times 5 equals to 15. So there are 15 red tomatoes originally in the bag. And the answer D is correct. Now let's go to the next question. Question 3. If P is a prime number, how many factors does p cube have? The answer must be true for any value of p. So plug in an easy prime number for p such that 2. The factors of 2 cube equal to 8 are 1, 2, 4, and 8. There are 1, 2, 3, 4, and 8, 4 factors. So the answer D is correct. In general, since p is prime, the only numbers that go into p cube, without a remainder are 1, p square, and p cube. That's the answer. Let's go to the next question. Question 4. How many integers between 10 and 500 begin and end in 3? For the two-digit numbers, only 33 begins and ends in 3. For three-digit numbers, the only possibilities are 303 and 313 and 323, 333, 343, 353, 363, 373, and 383 and 393. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We found 10 three-digit numbers and 1 two-digit number for a total of 11 numbers that begin and end in 3. So the answer E is correct. Now let's go to the next question. Question 5. A particular integer n is divisible by two different prime numbers p and q. Which of the following must be true? 1. N is not a prime number. 2. N is divisible by p times q. 3. N is an odd integer. First, recall that a prime number is only divisible by itself and 1. And that one is not a prime number. So statement 1 must be true. Since a number that can be divided by two prime numbers cannot itself be prime. Okay? Next, recall that every number can be written as a product of a particular bunch of prime numbers. Let's say that n is divisible by 3 and 5. Then n is equal to 3 times 5 times p1 times p2, etc., where p1 and p2 are prime numbers. So n is divisible by 3 times 5 equal to 15. Therefore, statement 2 must be true. Finally, remember that 2 is a prime number. 2 is a prime number. So n could be 6. Since 6 is equal to 2 times 3, statement 3 isn't always true, making C the correct answer. 1 and 2 only are correct. I hope it's clear. Please like and subscribe to my channel. Thank you very much.